How do people at the SFI, yourself included, think of complexity in such a way that it's enough to unify researchers in a number of different fields?
Yes, so this is much vaguer, and no question. And when I first joined this community, this was still this was still a big topic of conversation, trying to have a more precise definition, if you like, and also asking a question that follows from it: could you, in fact, imagine a universal theory of complexity? And which is sort of a corollary to a much bigger question. But so I don't try to define complexity, and I've sort of shrug it off. And I don't think I've ever called myself a complexity scientist, to be honest. I'm a physicist. That's how I identify myself, who works on problems that one could characterize as complex, and in fact are complex adaptive systems. And I would say most of the work that goes on associated with the Stanford Institute and other places that have spun off from it, are really to do with something that you could call complex adaptive systems. And I've just already referred to them in terms of emergent properties. But, typically they're systems that have a huge number of agents or constituents that are interacting and evolving, and are ones that have many different scales emerge from that. Both in terms of your body, you have obviously, nanosecond processes going on all the way through to your entire lifespan, which is maybe up to a century. So all those time scales are working together. And one of the big challenges, of course, in trying to understand a complex system is, in fact, how do those multiple scales, both in terms of both space and time, how do they work together? I mean, how does that all happen in a coherent way so the system can remain sustainable? And of course, that's now an enormous question for the entire planet. I mean, because the entire planet is, of course, a complex adaptive system containing a huge number of agents in it with multiple scales, both, again, spatial and temporal, with these levels of emergent properties. So I think, and crucial in it, which makes it so hard, is, of course, not just these multiple levels, but also the fact that the system is continually evolving, especially in reaction to externalities. So that's sort of a summary. And oh, by the way, I think one of the things I should add to that is that I think it's useful to compare the word complex with complicated. So, here's an example. So, think of a Boeing 787. That is, I would say, extremely complicated, but, and I'm stretching it here, not complex. Now, why I say that is because somewhere in Boeing Aircraft Company, there's a big book that tells you how to build a Boeing 787. That's what they do. Which means, in principle, that an intelligent person could build a 787. There's an algorithm. You just follow. Now, of course, you can't do it. You have to have. But in actually building the 787, you create almost certainly a complex adaptive system. And that's what Boeing did, because you have to have all the suppliers and all the supply lines, and you have to have all these different kinds of workers with different technical skills. And you form a community that has to do this, and you have to make sure that, the engineers are doing their job, and the guys sweeping the floors, building the aircraft is doing it. All these things are happening at multiple levels, and that's the complex system, the complex part of a Boeing 787, not the machine itself. It's the structure or the process or the networks that are the kind of underneath the surface that you don't see that is producing that machine. So that's complex, and that is, of course, again, adaptive. A machine is typically not adapting. I mean, it makes that flight time and time again, and that's it. That's what it does. Your car does the same thing. It doesn't evolve in any way.
Right.
And
It also doesn't have multiple levels of complexity.
It doesn't have multiple, so it's, it is what it is. And so I think it's very important to distinguish complicated from complex. And one of the extraordinary things about the universe, I think, is that the universe out there seems to be just complicated, not very complex. I mean, all the complexity seems to be here on this planet, as far as I can tell. As far as we know, you could say the clouds of Venus are complex because clouds, hydrodynamics is a sort of complex system. It's not very adaptive, but complex adaptive systems so far only exist on this planet. This messy planet seems to be the only place in the universe that we know of. Elsewhere, it's all simple. That's why, you can have Sean Carroll on your program, and he can tell you all about the wonders of cosmology and quantum mechanics and all the rest. He can write down, here's the crucial point, he can write down, he didn't do it on your program probably, but he can write down the equations. And there's just a few of them. There aren't very many. And that whole thing, is kind of extraordinary. One equation, two equations, that encompasses enormous amount. You can't do it for a city. You can't do it for your body. You would have to, and put it slightly differently, if you insist on having the mathematical physicist view of the world, and you insist that in the end it is all of that nature, you could imagine writing down an equation for everything that composes of your body. And I would contend there is effectively an infinite number of equations that it would require, which would mean it's useless.
And based on this way of thinking about complex adaptive systems, cities and organisms both have multiple levels of sophistication. They're always changing and so on. Would you agree then that one of the purposes, just putting this all together, one of the purposes of this line of research is drawing connections, in this case, scaling laws, one of them, between different complex adaptive systems?
Yes. So one of the things that is sort of, a corollary of having this worldview is that it is inherently interdisciplinary or transdisciplinary. It inevitably means that you're thinking across traditional boundaries, and I think that's one of the great contributions of the Santa Fe Institute, was not just putting, quote, the word complexity and complex adaptive systems, so to speak, on the map, but also really showing what a transdisciplinary collaboration is. When I sort of laugh sometimes when people say, yes, at Stanford we have lots of these transdisciplinary, the high energy physicist is working with the atomic physicist. And I think you must be kidding. You tell me, what you have to tell me is that the anthropologist is working with an economist and a mathematician on some problem to do with, pre-Columbian cities or, I don't know what, the emergence of language in Bali. I don't know. Then I'm interested. That's so that's what happens at the Santa Fe Institute. And it's quite extraordinary that it happens. And the Santa Fe Institute is just this facilitator of bringing those people together who are, they choose it themselves. They self-select. We do go out, obviously, if you hear, we do try to get people into the orbit, but the vast majority, I would say well over 90% of the people associated with the Santa Fe Institute are self-selected. They come there. One of the mechanisms, by the way, since we're on it, we have lots of workshops and working groups. They're sort of on a continuous basis on all kinds of fantastic subjects. Also some mundane subjects, of course, but we do have a lot of these workshops and typically in organizing those, organizers are encouraged to invite people that haven't been to the Institute and might be interested and so on. And that's how many people get involved with the Institute. Many come and might enjoy a few days, but decide this is not their cup of tea, it's not of interest, or they think it's all flaky or whatever. That's it. But so it's an interesting, distributed, loosely connected, sometimes very strongly connected community that is a very interesting, different model than the canonical university structure, and is very complementary. And most people that are associated with the Santa Fe Institute have appointments in institutions, in major, academic institutions. So it's a kind of hybrid.